the other methods that I teach. I don't usually use it, but I will, if you want, I'll show it to you. I don't really care. But before I do that, I want to do these three in the method that I did already show you. Now, you all agreed yesterday that you weren't big fans of guessing and checking. So, but this one is not a bad one to try guess and check on because, of course, the numbers are small and the choices are not complicated, right? Like it has to be 2 and 1 and 2 and 3 or 6 and 1, right? So it's not too bad to try guess and check on. But we shall carry on. So, let me get this just set up just right. There we go. So I need to multiply to 12 and add to 13. What is it? 12 and 1. And everything's positive. So it's 2n plus 12. 2n plus 1. That's got a GCF. What is it? 2. So that is going to become n plus 6. That doesn't have a GCF, so that's going to be 2n plus 1. And I'm done. Everybody should have been able to do that. Now, something that bugs everybody with my method, or this method, is in this case, we are throwing out that GCF, aren't we? Now, if I just gave you this, 2n plus 12, and told you to factor it, you would divide it by 2, and the answer would be 2n plus 6, wouldn't it? Normally. But in this method, the reason we are taking out that 2 is because the only reason we knew that it was part of anything was because we multiplied 6 by 2. So we got to get rid of it at the end in this method. Everybody cool? All the rest of the times you would not throw out your GCF. It's only in this method. Everybody okay? Now, let me ask you, and I'm going to ask again. No, I'm going to do all three, and then I'm going to see if people want to see one other method. Okay? Now, what Shitu showed you is exactly the same as what we're doing, isn't it? Except instead of leaving the 2 there, you put the 2 over here, and then we get rid of it. It's the same thing. All right, so at this one, I need to multiply to 12 again and add to 8. What is it? 6 and 2. So it's 3t plus 6 and 3t plus 2. That's got the common factor of 3, t plus 2, and 3t plus 2. How do you know if you did it right? You check. Is t times 3t 3t squared? Yes. Is 2 times 2 4? Yes. If the ends are right, the middle's right. Okay? And last one, I need to multiply to 14, add to 15. It's 1 and 14, obviously. 2m plus 1, 2m plus 14, divide by 2, 2m plus 1, m plus 7. Is everybody good? You must stop me now if you're not okay with this. Now listen to me. Oh, sorry, Nino, go.
Oh, I was just wondering, how can you just divide 1/2 of like the end product? Like you can divide just one side.
Because this doesn't have any GCF.
I was just under the impression, I guess, that the entire time you had to divide everything.
All right. Everybody can use this method? Do you want to see the other two? It takes like 2 minutes. Because it might help some of you. All right. Let's use this one right here. One of the other methods is actually really, really useful for higher level factoring. So it's not bad to have seen it. Okay? So let's take this one right here. 2m squared plus 15m plus 7. All right. So, we all agree that it's this 2 that is causing problems, yes? Because if that 2's not there, we multiply to 7, add to 15, right? We can do that in our sleep. It's the 2 that's messing us up, yeah? So, follow me along. This, if it's 1, we know what to do, but now it's 2 times bigger, yes? We've talked about this. It's the same method as the first one I showed you. This one is 7. So we need to make that 2 times bigger. So that this method starts the same way. We still need to multiply to 14 and add to 15. Now, we know that it's 14 and 1, right? Now, this is something that you're allowed to do with complicated polynomials. Watch what I'm about to do. 2m squared plus 1m plus 14m plus 7. Do you all recognize that these 2 are there as my 15? Everybody cool with that? So now I've gone from a trinomial to a 4-term polynomial, yes? Now these are some things you're allowed to do in math. I can group those. I can put brackets in because it's going to give me the same result if I know what m is, right? So this, you see, has now, if I only showed you this bracket, you would GCF that, yes? What would you bring out of there? M. So you'd have an m, and then you'd have 2m plus 1, yes? What would you take out of here? 7 plus 7, and that would get you 2m plus 1. Now, doesn't that look exactly like that before we changed it? Right? So now, you see that this and this are factors, aren't they? And they're common, right? So we could bring them to the front. Then that's going to cancel, leaving me with m. That's going to cancel, leaving me with 7. This method is called decomposition. It's the way I was taught to factor these. A lot of kids have a lot of trouble with it. That's why I don't show it. But when you get higher up in math and you have to factor something that looks like this, a to the 4th plus a cubed minus a squared minus 9. If I asked you to factor that, most of you would say you can't, right? Because there's no common factor, is there? Oh, no a there, right? But if you group them, all of a sudden, what's that? It's perfect square, so that's a plus 3, a minus 3, isn't it? And what's coming out of there? A squared, leaving me with a cubed, leaving me with a plus, what's a cubed divided by a cubed? 1. And now you can factor tougher stuff because you can do this grouping move. Do you need to know this right now? No. Do you need to know that you're allowed to throw brackets into something and make it still work? Yeah, that's a useful math tip to have. Everybody cool? Okay. Now the other method, again, you don't have to know it, but I do want to show it to you. Starts the same way, but instead of doing 2m plus 14 and 2m plus 1, instead of doing that, we do m plus 14 and m plus 1. Now, the reason it's 14 and 1 is because we multiplied by 2, right? So we still have to divide by 2. Now, would you ever leave that fraction, Miss Bag Crumble's class? What's 14 divided by 2? 7. That fraction is as reduced as it's going to get, right? When you get a fraction as reduced as it's going to get, you take that number and you move it to the front. And it's called slide and divide. So I get m plus 7 and 2m plus 1. See how it's the same thing? Now, a lot of kids don't dig this because they're scared of the fractions. And they don't understand why that 2 can move there. They don't get why. And I explain it, but they still don't get it. So, just to do my due diligence as a math teacher, I'm going to explain it to you as well. In blue there, what bothers you? The 2, yes? I can't get rid of the 2 because it's not a GCF, right? So I got to use one of my other methods. But watch what happens if I get rid of the 2, okay? If I get rid of that 2, I have m squared plus 15 halves m plus 7 halves, yes? Does everyone agree? Same thing, right? Now, I've only got an m there. So if I could find numbers that multiplied to 7 halves and added to 15 halves, would I have this factored? I would, wouldn't I? Everyone agrees? All right, now, right here, notice I had m plus 7 and m plus 1 half, right? Everyone agrees? What's m times m? M squared. What's m times a half? M times a half. Holy crap, everyone. What's 6 times a half? So what's m times a half? Half of m. Plus 7 m's, right? Now, isn't 7 m's 14 over 2 m's? It is, isn't it? And what's 7 times a half? 7 over 2, right? What's 1 half plus 14 halves? 1 plus 14, people. 15 over 2m plus 7 over 2. See how that is that? So all I did was, when I get to here, this 2 bothers us, right? Right? The shortcut is to slide it to the front. But really, what I am doing is, how do you get rid of divided by 2? You multiply by 2, correct? So these 2's are going to cancel. There's my 1, and 2 times m is 2. There's my answer. So now you have all 4 methods. I don't care which one you use. Who has to make the decision? You do. So let's go back over to where we were. 9, 10, 11, 12, 13, and 14 are all pretty simple, so I'm just going to write the answers. You tell me if you need me to go over them, all right? 3t squared plus 2 squared. Or, of course, 3t squared plus 2 times 3t squared plus 2. Both of them are okay. This one is, let's get a good color going. What? You can't see? What? Do I need to zoom in? Better? I'm sorry, it's the best I can do. Oh, the internet's back! The internet is back. Woo! All right. So this one is y plus, I can't do that one in my head anymore. Two y minus 1 and y plus 4. Yep. This one is 3n plus 1 and 2n plus 3. This one is m minus 2 and 4m minus 5. Sorry, plus 5. No, I'm wrong. Plus 2 minus 5. This one is 2a minus 1 times 2a minus 1. And this one is y plus 7, y minus 7. Is everybody good? Yeah? We're all good? Everyone's cool? All right. Now, I told you to stop there because these ones are tricky, right? Now, looking at 15, and I think I've done one or two of these for you like this, but I can't remember because I'm doing factoring with all my classes right now. What is something that you might want to do with 15? You might want to expand, right? Because you see this squared. Everyone agree? So that would give me x squared minus 14x plus 49, yeah? Everybody's happy with that, right? Then minus 81. Agreed? Now what would you do with that? Are those like terms? So what would we do? We'd do that math. What's 49 minus 81? Negative 32. Everyone agree? Now, I have nothing out front, so if this is going to factor more, I need to multiply to negative 32 and add to negative 14, right? Is it 1 and 32? Is it 2 and 16? Yes. How do I get 2 and 16 to give me negative 14? So I get x minus 16, x plus 2. Everybody cool? Everybody cool? All right. Now, observe. I'm going to write something right here. A equals x minus 7. What does that mean? X minus 7 is a base. I agree. A equals x minus 7. What do you see right there? So what can I write there? A squared minus 81. Now, isn't that a plus 9, a minus 9? And isn't a x minus 7? X minus 7 plus 9, x minus 7 minus 9. X plus 2, x minus 16. Does everybody see that? It's a little shortcut. You still got to do quite a bit of work, but it makes this look much prettier. Do you have to? No, of course not. So let's look at 16. Would it be okay to expand that, collect all of your like terms, and then factor the resulting polynomial? That would be okay. How long would it take you? How long do you think it would take to do all those steps? Nino says a while. It might take a while, yes? But what do you see right there, there, and there? I see a squared minus a squared, right? And I know that any time I have squared minus squared, I have x plus y and x minus y, correct? We know that, right? So what if I say this is x and this is y? Everybody cool? Then I have x squared minus y squared, which means my answer is x plus y times x minus y, correct? What's x? Hey, Gerner, what's x? Exactly. Sit there. Take your earphone out. If I see your earphone in your ear again in the rest of the year, I get whatever it's plugged into. What is x? 2x plus 3. What is y? 4x minus 7. What is 2x plus 4x? What is 3 plus negative 7? Would you ever leave that in this class? Why not? Always GCF. So what is that going to become? 2 times 3x minus 2, correct? Everyone agree? Okay. That's the first part. That's the x plus y. Now we got to do x minus y. What's x? Minus, what's y? What's 2x minus 4x? And what's 3 minus 7? Would you ever leave that in this class? So what do you need to do? What kind of 2? To get x minus 5, right? Everybody still with me? What do coefficients do? To get what? 3x minus 2 and x minus 5. And we can do all that without ever once expanding. Now, don't write down what I'm about to do, but look at what happens if I try to expand it. 2x plus 3 times 2x plus 3 plus 4x minus 7 times 4x minus 7. Sorry, minus. So that's 4x squared plus 12x plus 9 minus 16x squared minus 56x plus 49. And then almost all of you are going to forget this negative changes all these, and you're going to screw this up. You're going to get negative 20. Sorry. You're going to get negative 12x squared. 12 minus 56 is positive 68x. 9 minus 49 is negative 40. Now you've got this yucky trinomial, which you would then have to factor. Or you can do addition. Who makes the choice? You do. I have a kid in grade 11 that would rather cut his eyes out than do this move. He says, and I quote, expand or die. He wants to do this every time. Look at how much work it is. But he's welcome to it. This is a nice, easy one. What is it? x plus 2, x plus 6. Now, look at this one. Are we going to do expand or die? I wouldn't, because what do I see right there and there? They're the same thing, aren't they? So can I make that any other letter? I always choose A, but you don't have to. Q squared plus 8Q plus 12. Isn't that the same as that? So isn't this Q plus 2 and Q plus 6? Right? And isn't Q 2x plus 7? So doesn't that make this 2x plus 7 plus 2? And what does that make this one? What's 2x plus 7 plus 2? 2x plus 9. What's 2x plus 7 plus 6? 2x plus 13. And I'm done in 3 steps. If you want to expand and collect all your like terms and factor a trinomial that looks like that, expand or die. Or you can learn that very handy math trick of substitution, which you all already know, don't you? Because if I wrote this, x squared plus 39x plus 17, barf. But if I tell you x equals 1, how easy is that? 1 plus 39, 40, plus 17, 57. You already know how to substitute. So why wouldn't you use that math tool in other spaces, right? So let's have a look at 19. What do you see there and there? Same thing. Do you want to expand it? All of you do this with my trick. If I expand it, I'll show you what the trinomial is going to look like. Do you want to factor that? Like, honestly, do you want to do 16 times, well, wait, we could fix it up. 8x squared plus x plus 23. Do you want to do 8 times 23 and then do the math? I don't. So I will choose to substitute. I am going to make this. What letter do we want to make it today? P? Sure. Oh, wait, it's P. We'll do it yellow. P, P. So now I have P squared minus 4P minus 45. And how difficult is that? What do I got to multiply to? Negative 45. What do I got to add to? Negative 4. Is it 1 and 45? Is it 3 and 15? Is it 9 and 5? Yes. How does 9 and 5 get me negative 4? 5 minus 9. P minus 9. P plus 5. But what's P? So what's 4x plus 3 minus 9? 4x minus 6. And what is 4x plus 3 plus 5? Would you ever leave those in this class? Why not? Always GCF. What's the GCF here? So what's coming to the front? 2x minus 3, right? What's the GCF here? 4. What's coming to the front? 4x plus 2, right? What do I do with 2 and 4? 8, 2x minus 3, x plus 2. And then you're done only using that thing that you can do easily in your head almost. Or you're doing a giant ugly trinomial. You decide. I don't care. Everybody cool? Everybody cool? Tomorrow I'm going to give you a quiz on factoring. It will be heavily weighted towards GCF, because GCF we use all the time. Then expect at least one of every other kind of factoring. All right? We'll do that tomorrow, because tomorrow's a short day. It's like 35 minutes or something. Huh? What?